Okay, now we'll start working with fractions, and the first thing on our list is just definitions. Fractions can be written in different forms. We have proper fractions, improper fractions, and mixed numbers. Proper fractions are bottom heavy, so the bottom is greater than the top. Improper fractions are top heavy, so the top is greater than or equal to the bottom. And then a mixed number just has a whole number and then a proper fraction after it. So a proper fraction would be like 1/2. The bottom is bigger, or 41 over 207. Any fraction where the bottom is bigger than the top is a proper fraction. Improper fraction is any fraction where the top is bigger than the bottom, like 4/3, 401 over 207. Also, 7 over 7 would be an improper fraction, because look at the definition closely. It says where the top is greater than or equal to the bottom. Then we'll have mixed numbers, where we have like 4 and 3/5, 2 and 1/2. Now what about 6 and 8/5? Is that a mixed number? At first glance it looks like it is, but that 8/5 is not a proper fraction, so that doesn't count. Now somebody's asked, what is it then? Well, it's either a mistake or it's not finished. There's ways of converting it to what we need to do, but that will come in a few slides. Okay, I want to just be able to look at what this is. Let's just say that those are pizzas for the sake of argument. How many pizzas do I have? Well, first thing you'd say is we have 2.5 pizzas. That's the easiest thing to see. We have 2 whole pizzas and then a half pizza, so we have 2.5 pizzas. That's a mixed number. What if I wanted an improper fraction? Okay, there's a point here where people do get a little bit turned around, so I just want to spend a little bit of time on this. Well, I have 5 pieces, so I know 5 is my numerator. I have 5 pieces, but what's my denominator? To find the denominator, you're going to look at one unit, whether it's one pizza or one cake or one baseball field or whatever it is, one unit, and see how many pieces that one unit was divided into. Since that one pizza has been divided into halves, we have 5 halves. The mistake I see people making is that they will see 5 pieces, but 6 spaces, so they'll say 5/6. That 6 doesn't go in the bottom. The way you know the denominator is to look at one whole thing and see how many pieces that one whole thing was divided into. All right, those are our definitions. Next we will have prime factorization. So a prime number is a number whose only factors are 1 in itself. The only way it can be written as a product of 2 numbers is to multiply 1 in itself. It can only be factored one way. They're all just different ways of saying exactly the same thing. So if I tell you that 2 is the first prime number, what's the next one? Yep, 3 is prime. How about 4? 4 is not prime. 4 is 2 times 2. But 5 is prime. How about 6? No, 6 is 2 times 3. How about 7? Yes, 7 is prime. How about 8? 8 is 2 times 4. How about 9? Nope, 9 is 3 times 3. How about 10? Nope, 10 is 2 times 5. How about 11? Yes, 11. 12? No. 13? 14? No. 15? No. 16? 17 is our next. 19, 23, 29, 31, 37, and we could keep listing forever. A composite number is a number that's not prime. So for example, 20 is composite because 4 times 5 is equal to 20. Okay, is that the only way to factor 20 as 4 times 5? No, there are several ways. We could say 20 is 4 times 5. We could say 20 is 2 times 10. We could even say 20 is 1 times 20, even though that's kind of silly. Now, can we factor the factors of 20? Let's go look at the first one. 20 is 4 times 5. 5 can't be factored, but 4 can be factored into 2 times 2. Okay, how about 2 times 10? Well, the 10 can be factored. No matter how we start, we're always going to end up with the same thing. So that 2 times 2 times 5 that we're inevitably going to end up with is called the prime factorization of 20. The prime factorization of a number is writing a composite number as a product of prime numbers. How do we get there? Well, with 20 it was easy. With bigger numbers it might be a little harder. We can do what's called a tree diagram, and we'll do 2 examples on the next slide. Okay, we'll do 70 and we'll do 136. Now what obviously goes into 70? Well, 10, because it ends with a 0. So we can say it's 7 times 10. 7's prime, can't go any further. 10 is 2 times 5, so those are my factors. So we know 70 is 2 times 5 times 7. Now 136, that's not in our times table chart, but we know it's even. An even number is always divisible by 2, so we could say it's 2 times 68. 2 is prime. Now 68 is still not in my times table chart, but it's divisible by 2. So don't worry if you can't see all the factors. If you can just get one of them off, you're going to make progress. 34 again, that's not one we necessarily recognize right off the bat, but it's 2 times 17. Oh, we got all the way down to prime numbers. So 136 is 2 times 2 times 2 times 17. And we found the prime factorization of these numbers. We're going to use prime factorization 2 different times today. So the first time we use prime factorization is going to be in reducing fractions. First of all, what fraction of this circle is red? Well, half of it, obviously. How about this one? Well, half of it's still red, but how else would we write that? That circle's been divided into 4 pieces. 2 of them are red, so 2/4. And this one, 4/8. But as I'm sure you've noticed, in each case, half the circle is red. They all mean the same thing. These are called equivalent fractions. 1/2 is equivalent to 2/4, which is equivalent to 4/8. They all mean the same thing. Well, if they all mean the same thing, which one's the best one? Well, 1/2 might not be the best, but it is the most common. A fraction is in lowest terms if the numerator and denominator have no factors in common other than 1. So for 1/2, they don't have any other factors in common, so it's in lowest terms. But 2/4, they both have a 2. 4/8, they have some stuff in common. So we need to get a fraction in lowest terms. The first way we'll do that is to use prime factorization, and then I'll show you a little bit of a shortcut after that. So for 4/8, I'm going to say, well, 4 is 2 times 2. 8 is 2 times 2 times 2. If you can't just see that right off the bat, it's no problem at all. Just do a factor tree. Now, if we have things in common in the top and in the bottom, I can cancel them out. You need to be careful to replace them with ones, and I'll talk about that more later on in class. And so everything canceled. I have 1 times 1 on the top, 1 times 1 times 2 on the bottom, and I can see that 4/8 is equivalent to 1/2. Very easy example. Let's do some that are not so easy. 6/16. Well, 6 is 2 times 3. 16 is 2 times 2 times 2 times 2. Cross out what's in common, and we get 3/8. 3/15. 3 doesn't factor. 15 is 3 times 5. Cross out what's in common, and we get 1/5. Now, the reason I've had you replace those canceled factors with ones is I can't tell you how many times I've seen people cancel those 3's, and then they say, okay, there's nothing left but 5, and they say 5 is their answer, and they circle it. So those ones are very, very useful as placeholders so that you don't accidentally make a mistake. Okay, here's another way to think of it. These are a little bit harder, and I'm going to show you a shortcut. So if we have at the top and the bottom have a factor in common, we could just divide by that common factor. So rather than listing the prime factorization of 70 and the prime factorization of 120, I could say, well, I know they're both divisible by 10. So let's divide them both by 10, and I get 7/12, and I'm done. Because 7 and 12 don't have anything left in common. Now, what about 36 and 210? Well, they're both obviously divisible by 2. Also, 210 is divisible by 3. One way we know that is if you add all the digits, 2 plus 1 plus 0, that's 3. And that's divisible by 3, so the original number has to be. So let's divide them both by 3. So we get 12/70. Now I am not done because 2 goes into both of those. So I have 6/35. And now 6 and 35 don't have any factors in common. 6 is 2 times 3. 35 is 5 times 7, so they don't have anything in common, and I can't reduce. Okay, 119/210. Now 119 is tricky. It's not divisible by 2. If I take 1 plus 1 plus 9, I get 11. That's not divisible by 3, so 119 is not divisible by 3. Not divisible by 5, not divisible, well, let's see if it's divisible by 7. Use a calculator, and I know it's 7 times 17. 210, if I do a factor tree, is 2 times 3 times 5 times 7. What do they have in common? 7s. Cancel those and I have 17 over 30. So one thing that you might want to be aware of is that some fractions are just irreducible. So if they don't have anything in common, they're not reducible. You can't do anything with it. That is reducing fractions, and that will be the end of this slide, and then this video we'll do multiplying and dividing on the next video.